Ion exchange chromatography is used to separate biomolecules based on differences in their net charge at a particular pH. The charge of the protein is dependent on the number and type of ionizable amino acid side chain groups. Each protein has an isoelectric point, PL, a pH at which the overall number of negative and positive charges is zero. Buffered solutions below or above the protein's PL are used, depending on the charge of the protein. The protein binds to the opposite charged functional groups in the resin. In principle, a protein could bind to either a cation or anion exchange resin, but in practice, proteins are only stable within a narrow pH range, and the choice of resin depends on the pH stability of the resin. So, how does the separation work? So, ion exchange chromatography works by separating proteins based on their total charge. As proteins pass through the resin, it will be dragged over a long distance depending on the charge of the resin and the protein. So, the kinds of substances. The kinds of substances that ion exchange chromatography is used to separate include different biological molecules and proteins, amino acids, and nucleotides. So, how does the apparatus work? So, there is a glass ion exchange chromatography tube that is held upright by a rito stand. In the ion exchange column, there is a buffer, which is pH depends on which protein you're using. Then you have the main part, which is the resin, which will be used to separate the protein. Below, you have a level of glass wool, which is used to then filter out the solution at the end. And at the bottom, you use a gate clip to hold in the elutant, which is then pumped through the ion exchange column. So, how much does this cost? Well, ion exchange chromatography can be quite expensive and usually costs between about $2,000 and $2,500, which most of this cost is due to the ion exchange column, which has to be specially made just for this purpose. The ion exchange has a variety of applications in research. It is used for the analysis of raw materials, bulk active ingredients, counterions, impurities, and degradation problems. In addition to research, ion exchange chromatography is also used in industry. Some of the uses are the production of equipment cleaning solutions, waste streams, and container compatibility.